Good enough? Okay. Gonna keep going. What if a 12 lead alternator, we're gonna have them for low voltage connection. Then this time, how many split bulb will be need for this connection?
6.
6. Think again. Anyone else? 7 for low voltage. Are you gonna connect those coil in parallel? So 4, right? Connect all the center together, then you need 3 connect onto the lines. Those are kind of like an IP question. Okay, installation for the generator. There's a municipal and a fire marshal. We give you, we be governed by them, and they will have some rules and regulations. Located as possible as to the main power supply. Usually in the building, they will have a special room or area for the generator. Mount on the vibration pads. So that's a type of my vibration pads. There's a different type. And because when the generator running, that will be causing lots of noise and vibration. So the vibration pads is try to reduce the shaking movement. Avoiding area have a actual high or low temperature. If on the outside, the engine must be keeping warm, use a block heater, and the battery also have to keep warm. Otherwise, in the winter, they're not going to be so easy to start. At the quarter field must be available for power outage and exercising. So generator exercising is also an important and requirement. So here's a picture showing you have the battery down here. The battery is for needed for starting the generator, and then you have a exhaust pipe down here. You have the fuel tank down here. So few questions down here. They ask you why the flexible exhaust hose connection. Because when generator running, they usually will be vibration and the movement, right? So you need a flexible hose. The battery is so close to the generator because you don't want to use a longer cable, so you will have a voltage drop on the cable, and that will gonna cause a starting problem. The need for the battery is for starting the generator. Okay, here's the important thing. So we have a battery. When the battery is hooked up onto the generator, when you try to remove those battery, or when you try to reconnect the battery, there's certain type of the sequence you got to follow. And do you guys remember, if you're working on the cars, when you remove a battery, which terminal you remove first, which terminal you remove next? When you connect a battery, which terminal you connect first, which terminal you connect next? Yes, no? Yeah, so that's right. And I think, Justin, you are using some type of YOLO. YOLO. What's YOLO? You only live once. Okay, so this is an important question, and you need to know them. When you disconnect, you remove the negative first. When you then remove the positive, when you connect them, you connect the positive first, then you connect the negative next. Okay, millennial to linear version. Okay, watch you guys' language. Okay, we don't know. I know we are all the trained person, but it's here we are in the class. Might have people can get offended by those wording. Might have girls or anything in the class. Yeah, flexible connection is to avoiding the vibration and reduce the uh, reduce the chance for disconnecting. If you're ever working on the job, I think the chance to hook up a generator is not so much. But if you ever hook up a motor, a decent sized motor, you will bring with EMT or rigid or PVC or whatever to a junction box next to the motor. But the last piece to connection from that junction box to the motor's uh, terminal box, you're always using either the flexible core or something. Yeah. The voltage drop is related to the battery have to be put close to where the generator is. If they got too far away, because when they start, they draw large current, and if the uh, wire is longer, the resistance too high, then you might not have enough voltage at the generator terminals. A control panel, you usually have a generator control mount at on top of the generator panel. Yes, you're right. This control panel will be all different, depends on the manufacturer, and it depends on if you're working on a new generator or old generator. The new one usually have a little bit of slightly larger monitor, can display lots of functions, and the old one will be slightly, some of them only have mechanical buttons. So that would be all different. Yeah, the modern one, we have a human machine interface. You can easily have a touch screen or those things. And it's programmable, allow for regular exercising. Then we're talking about disconnect and reconnect the battery. We're not talking about the current flow. The backup generator or emergency generator, they usually have an alarm. The fire alarm system will hook onto the generator also. They will have the alarm for, like, if you're low on oil or coolant or anything, they will send out the uh, alarm to the either the building monitor panel or to the fire alarm panel. This is an old type of control panel. They have few meters, can show you the amps or volts, frequency, hour running, circuit breakers. So this is a pretty old. You're probably not going to see the new generator coming in this version anymore. Parallel AC generator. Sometimes you require more than one generator, and the, the the new system usually like the hydro system, right? And they usually we have those automatic controls. I know in year 3 you probably learned how to parallel generator, those type of thing. But the ITA or the one they teach you in year 3, it's still old version mechanical way how they can parallel generator. You have those they usually talk about either three lamp to use for synchronized generator, but modern one is all done by the electronic controller inside. They first we get generator online and make sure the voltage and everything is stable. Then they will connect the load on there, and then they will automatically synchronize other generator with the first one online and to share the load. To parallel generator, they will have the same terminal voltage, they will have the same frequency, and they also will have the same phase frequency. And also on the waveform, the voltage have to be in phase for each of them. About the generator, there's some special thing you have to know. Is I think it called sharing the loads. So in year 3, you guys probably learned something. It's called a governor. The governor is to control the generators, control generator speed, or we can call generators prime mover speed. With the electrical load. So the governor is actually controlling the input mechanical power, because when you increase the electrical load, you require the generator to working harder. You will automatically try to slow the generator down. But when the generator speed changes, we know the frequency, the voltage are going to change. So the governor, we try to make sure the prime mover providing extra mechanical input power to the generator. So you try to keep constant speed. So the speed gonna keep constant, and it doesn't matter how the electrical load gonna varies. So that's the purpose of the governor. And another thing is we call the to adjust the generator or to share the load. Share loads between parallel generator. To share the loads, if you have a two generator, this gen 1, this gen 2, they both are hooked up onto the supply line, and you got a bunch of loads connect on here. Generator 1 starting first, so you carry the load. If you want to share this load with generator 2, what you're gonna do is you're gonna reduce the prime mover input power, or another way is you just adjusting the governor here. For generator 1, you try to decrease, and you're gonna increase the governor on generator 2. So you try to increase the prime mover's input power. That's for sharing the true power, or sharing the power between different generators. Usually they have two controls. One is for controlling the speed. So the speed control. The speed control usually is the governor for controlling the prime mover speed. So you can you have to do at both at the same time. So you reduce the speed control of the governor for generator 1, and you increase the speed control of governor for generator 2, and they will transfer the load to the second generator. Another one is called sharing. I don't want to make a new drawing, so I'm just going to flip to next page. They call the sharing the KVAs between parallel generator. So when you're sharing the KVAs, you are trying to do is adjust field excitation. When you adjust the field excitation, you are changing the kVARs of the generator. So if you reduce the field excitation on first one, you are reduce the VARs output by this generator, and you increase the field excitation on there, you're gonna increase the VARs on the second generator. So because your load might not be a truly at 100% power factor, your load might have some those power factor lower than unity, so you might want to share some VARs between the generator. So to sharing the kVA or sharing the VARs, you're adjusting the field excitation. When you're sharing the true power, you're gonna adjust the speed controller or governor for the prime mover. Okay for this one?
Yep.
So this will be something important. You're probably gonna encounter a question to ask you this. I'm just gonna leave here for a second. If you want to take a picture, you can take a picture. Good. So that's talking about how to share the true power and the shared kVA between parallel generator. This is a sample operation of those backup emergency generator. When you have a normal power, you have this overcurrent device for protecting, and your load is always connect onto the normal power side. ATS is the automatic transfer switch. Those is your emergency generator. So when power fail, first you gotta start the generator. The automatic transfer switch, we send the signal to start the generator. When generator starting, those are not connect onto any load, they just run by themselves. That's why it's called a floating offline. When generator 1 gets up to the rated voltage, the frequency, the control, we connect it to the common bus. This is the common bus. Then the automatic transfer switch, we connect the critical load, or we call the, in this case, they call the critical load, or sometimes they call the another name called essential load, to connect onto the common bus, because maybe generator 1 only can supply a certain amount of the load, so you cannot add other load on there. This could be programmed to do the control is you always connect an essential load or critical load first. Then generator 2, we also brought online to the common bus. And this one will also be automatically synchronized to the common bus, because generator 1 get up early first. So when they connect, there's no synchronization to go on here. But when second one, when they try to connect onto the common bus, they will automatically synchronize on there. So once generator 2 is connected, they could share the load with those two, or they can bring more load on there. So in this one, your critical load will always connect on to the automatic transfer switch 1. They will bring online first, and the essential load will be bring online later than the critical load. Reverse power relay, that's the RPR. Talking about synchronized unit have RPR protection because you don't want to feed the power back. One of the generator goes into the speed drop, you will unable to pick up the share of the load due to the prime mover and the governor affair. So other generator, we're working harder and we're acting as a low instead. So what they try to say here is if one of the generator have some kind of problem, then it's not going to supply power to the load, and because it's a speed dropping or it's excitation dropping, this generator will actually try to draw power from other generator. When this generator try to draw power from other generator, you will have a, they call a circulating current between the two generator. That's a really bad situation. So the reverse power relay is preventing that. So if this generator got a problem, they cannot supply power, they will be disconnected from the common bus, and they're not gonna be draw power from another generator to causing that circulating current just go between these two generators. Plan exerciser. So this part is also pretty important. The standby generator, they should be running for at least 30 minutes per week to ensure they will be reliable starting in a real situation. So 30 minutes per week, that's a kind of requirement for the exercising a generator. In here, it said prefer to do under 40% low, but a full low is the best. So we will say prefer to do this under full load situation. So every week you need to turn on your generator to run at least 30 minutes under the full load situation. Okay. So those short-term starting running generator is considered as exercising the generator. So you need to know this. This is pretty important. And if you have an automatic transfer switch in there, you usually will switch your transfer switch to test location, and then you can run your generator to do that. This exercising is try to boosting the charge to the battery because you have a battery connect onto the generator, and you always want to keep that battery at fully charged. So if you don't run the generator, the battery gonna drop, voltage capacity gonna drop down, and then when you really need it, you're not gonna be able to starting it. Clean the carburetor and of any sediments. So if you don't run them, there will be some carburetor buildup, some sediment buildup on the carburetor. Also, the running will keep all parts lubricated because you will have those oil circulating through the system. Bring engine up to the operating temperature. They will remove condensation. Those is the purpose why you always have to do exercising weekly for the generator. So there's some important thing in this page you have to know, or at least be able to answer the question. This is a typical testing sheet for this generator, and you will have a recording, a bunch of information on there. That's usually either done by the maintenance company, if you have a contract company for the generator, or by the maintenance personnel for the building. Transfer switch. All emergency power system incorporate a transfer switch. This transfer switch can be manual or automatic. Most common in commercial or industrial, you will use automatic. You will switch the load from the hydro supply to the standby or emergency generator. This automatic transfer switch also will start and stop the generator and transfer the load using a bunch of a motor and a bunch of time relays. The automatic transfer switch will does that by itself, so you don't need anyone to actually go into there to turn the switch to start the generator. The switch capacity matching the capacity of the generator. So if you have a 50 kVA generator, the automatic switch have to be rated above that. They have a bunch of control function. They will censoring the voltage and the frequency of the generator. We start the generator, monitor the generator's voltage. If any of the trouble in the generator, the circuit, they will be come with the trouble signal on the display, or we showing you in any building control system. When the normal power come back, they will also, when the normal power becomes stable, they will retransfer the load back into the normal supply, and we let the generator to cool down and stop the generator. Last one here is that allow for momentary AC bumper. This is talking about because usually the utility like BC Hydro, they have those, I think you guys learned in high voltage, right? They called those auto reset circuit breaker. So if you have a tree branch fall on a power line, it will cause a short circuit. So the short circuit will causing the circuit breaker to trip, but the circuit breaker will automatically reset itself if we try to reconnect them. So when it reconnects, if the tree branch just got a short circuit, they got a pushed away or bounced away, and there no short circuit happens. So the power will become supply will become normal. And for those type of situation, you don't want to be the automatic transfer switch to start the generator to start transfer the power, because your utility or hydropower might just come back in really quick. So you will usually have a time delay there. We wait to see if that's the situation, or is the hydropower or utility power is really off. Here is also important idea down here. The automatic transfer switch, we're providing positive interlock, or they call the break before making switching. The purpose is here, you don't want to the generator supply and the utility power supply come at the same time. Because for this one, this generator, you never got synchronized into the utility grid. So you're never supplied to feed the power back into the utility grid. That's why they need to have this break before make switch. So you will either connect on this side, then you will disconnect from this side, then connect onto that side. So that's break before make. And other type of the switch we're going to talk about later. There will be make before break type if you want to bypass something. So that's a important thing to know down here. Automatic transfer switch operation, when they lost power, the first we recognize, okay, the normal AC power is failed. Then they will wait, like the time delay, we wait to see if that's a real power failure. So it might be a bumper, just like maybe a tree branch or something happen a short moment. They're not gonna transfer the power over. After that, or at the same time, the circuit will control that. They will start the generator after another time delay, then allow the generator's voltage to build up and stabilize. Then they will operate the transfer switch to connect the load onto the emergency power supply. When the normal power returns, they will keep censoring even when the power is failed. They will keep the sensor there to see if the normal AC power will be returned. When that normal utility power returned and it's stabilized, they also have a time delay in there. Then they will retransfer the load back into the normal power supply. At the same time, they will allow the generator to cool down before shutting down. And they provide trip-free overcurrent protection doing all phases. So if you overload them, they will for sure gonna trip them. Here is a sample picture of that ATS. You have a selector switch on here. This selector switch have 4 settings: testing, auto, start, stop. So each of those have its own meaning. Testing is you try to start your generator and simulating the power outage situation. Auto is the normal position. So if you want to automatically switch to do its job, when the power loss, start the generator transfer, you always leave them in the auto situation. Start, if you want the generator to start, but it does not carry any load. Stop is you're gonna just use for servicing the generator. The ATS will not be, even if you lost power, it's not gonna transfer the power to the backup generator because you are working on the generator. Lockout, that's for the safety. So how do you lock out the generator transfer switch? You gotta put the ATS in the stop location, disconnect the battery. So once you disconnect the battery, the generator not gonna be able to start. Open and lock out the circuit breaker on the generator control panel, turn off the normal power, and perform a shutdown. So because the automatic transfer switch, they will always have power connect on either side. So you gotta disconnect the power from both sides, make sure generator not gonna be able to start, and make sure the normal power not gonna connect onto the automatic transfer switch. Then you can start working on them if you want to do maintenance or repair. This is the automatic transfer switch schematic. Like I mentioned to you, you will have a print reading question from this piece of drawing. Few things I'm gonna try to remind you first. You saw those one with HOT, TRT, WUT. Those, anything with a T on there, those are the contact, those are the coil. And the label down here, it tells you it's all on delay timers. On delay timer, we're gonna talk about what's that slightly later, so don't worry about it. Those on delay timer, in the motor control, you guys learned what a timer is and on delay, off delay. If the coil with this symbol, that's going to be the timer. You also have other timer. You can see here's a CDT. The T also indicating is the timer. Here's a CD. So this is basically a crank relay or crank disconnect relay. But this CDT is a crank disconnect timer, and you will timer delay on stop. And so when here the tricks they ask you, if they just said a CD, it's not a timer. Okay, CDT is a timer. So if you ever got asked a question in there, they said, oh, CD is a timer for this purpose. No, CDT is a timer. So I just try to remind you here. It's 12/12 and June 16th. So if you get that one wrong, don't come to me. Also, another thing I want to mention you down here is these two. Those are under voltage sensor or under voltage sensor relay coil, and you have a bunch of contact down here. Okay. My last class, somebody they encountered those type of questions on the exam. They said, "Oh, Jack, you never talk about." I said, "Hey, I got a video. I can show you where I talk about this in doing my class. So if you didn't get that, you skipped my class. Don't blame me." For this emergency contact down here, they tell you auxiliary contact maximum is 10 amp, 400 volt AC. So those EA1, EC1, EB1, or this NA1, NC1, NB1, those are rated for 400 volt AC at 10 amps. We usually call them Form C dry contact. So they have a normal open, normal close. And then you got those under voltage sensor. You have UVS1, UVS2, UVS2 down here. Those are spare contact. Those are rated maximum 3 amp at 28 volts DC. So those contact down here is related to these two under voltage sensor. Those EA1, EAB, EAC, I think it's come from here, EA, EA, EC. Then your NA, NC, NB, that's your NA, NC, NB. So those contact is related to those things. But those contact is using for AC power only. Those contact is using for DC power only. For those one, you cannot mix them, okay? The DC contact can only supposed to using on the DC circuit. The AC contact supposed to use on the AC contact. One more thing, those under voltage sensor, they are connected onto the normal power side. So here's a step down voltage. Wherever your supply voltage is, they're gonna step down to 12 volts. So UVS2 is connect between line B and the line C. UVS1 is connect between line A and the line B. this is 12 volts. You can see here, the terminal 1 of this UVSC2 is connect onto this terminal. This terminal is also grounded on these PTs. There are 2 PT to step the voltage down. So each of this UVS and the voltage sensor, we got 12 volts. But if I ask you a question, between this terminal at the bottom here on UVS1 to the top terminal on this UVS2, if I put a voltmeter between these 2 terminals,
24 volts.
Okay, let me see who answered this question. How many volts going to be? Nobody? All sleeping? Okay. Anyone tell me 24 volts? You're gonna stay to 5 o'clock tonight, because I'm gonna reteach you 3-phase transformer. It's not gonna be 24 volts. And also E-fan, you're gonna stay to 4:30. It's also not 20.78 volts. 6 volts. Sebastian, you're gonna stay to tomorrow morning, 6 o'clock. How these 2 transformer connected? What's the supply down this side? Is 3-phase Y or 3-phase delta?
Y.
What? Did you see any neutral in here connect onto your transformer?
Delta.
Did you see any neutral on here connect onto the transformer? No, right? You basically connect between all the 3 lines. So it's a delta. When you have a 2 transformer, is that an open delta? So that's an open delta. The voltage between here and here only gonna be 12 volts. Okay. That's not a good excuse. Okay, so make sure this is not 24 volts, it's only 12 volts. So you might encounter some question in here. They will ask you, what's the voltage down here? What's those form C dry contact? The form C, which means is you have one normal open, one normal close, and they're gonna be, if you energize the coil or something, they're gonna switch the state. This one will close, this one will be open. But to using them, this one is for AC only. So those one use on AC circuit, those one use on DC circuit. So you got to be read the prints and make sure you read those smaller letters. Anything else? Let me think. Yeah, and also the timer. Those are the timer. Those are the timer. And the other coil is just normal relay coil. They are now gonna be have time delay on them. Okay, now we're gonna look at how this is gonna work. So this is a instructor. He highlighted this in I think it's Jim. I don't know if you guys know him. Then he take the picture, upload onto the PowerPoint. So if it's not very clearly, you're still going to be, let me show you. So here's on your D2L, under the transfer switch, you will have a two document. Those documents will also tell you when lost power, how that transfer switch going to operate. When the power come back, how the transfer switch going to operate. So you better have those one, either print them out or have them handy. When you do this exam, there will be questions related to how this thing works. Or maybe just ask you, what's the purpose of this? What's the purpose of that? Okay, so first, number one here is UVS. UVS is the under voltage sensor relay. When normal power fail, those under voltage sensor relay gonna be de-energized because they depends on this PT to step the voltage down. So when the voltage lost down here, those I think it's a normal open or normal close. Just let me go back one page. So it's easy to see here. Those are the normal close one. So normal close one, when your normal power is here, the coil gonna get energized. Coil energized, those one will be open. But once you lost power on the normal side, those one gonna de-energize. When they de-energize, those coil gonna go back to the normal closed state. So it's sometimes a little bit hard to see on here because he took the picture. Normal power fail, those relay de-energize, and then those become closed. So this HOT, it's called hold over time relay. We're talking about that hydropower bumper. So this is for avoiding the bumping in the utility system to causing the transfer. So the contact become closed, energize the hold over time relay. So now this relay you got a 12 volt DC battery power. This battery power gonna go through those relay, gonna energize the coil down here. The hold over time relay energized, you begin to timer, wait to see if the power is truly off. When it's a time out, you will open the normal close hold over time relay contact. So this is a normal close. When this one energized, because this is a time delay, you will open this one. The time delay on retransfer relay drop out. So when this one open, this retransfer relay got a disconnect from the battery power. This one will be de-energized because at this stage, we want the power transfer to the emergency power. We now want to transfer the power back to the normal yet. When this retransfer relay falls out, the normal open contact opens and de-energize the cool down timer. So this is the cool down timer. And because this is normal open, when this one energized, we close that. When this one de-energize, we open that. So CDT down here is the cool down timer. The CDT de-energize, the generator with starting circuit is complete. So this, because you have a CDT down here, it's a normal close. When this one is de-energized, this one will be closed. When this one energized, this one become open. So now when this one de-energized, your battery power can go through this starter relay, go through here. We go to have a complete circuit. The starting relay energized. So starting relay energized, you will try to start the generator. So now the starting relay energized, you will also, the generator is starting, the alternator is starting. The overcrank timer is also energized and begin to timing. So this is, I believe, is overcranking timer. Let me see before the drawing. Yeah, so that's the one, overcranking timer. The overcranking timer is preventing, because your generator might be try to cranking start, but if after a certain time, just like your car, right? You try to turn the switch, try to start your car. If after a certain time, it's not starting, you're not gonna always hold your key in your switch, try to starting it. So once this one, because you also have a complete circuit here to go over, this timer start cranking. They said either this overcranking timer will time out, and your generator will de-energize, because if you're overcranking, you have a contact here with overcranking timer here. We try to open it. Once this open, you're now gonna be able to supply the power to the starting relay. So you will stop the starting cycle. Or if your generator have enough voltage build up here, so this is the generator voltage relay. It's connects through here, and once this one build up enough voltage, then you will have a generator voltage down here. You will have a contact here will be de-energize this overcranking relay. Let me see where it is. So the purpose is down here. So your power goes through here, goes through this, I think this called a CD, is a cranking disconnect relay. So if you got enough voltage, because another side is connect onto the neutral. So this one, if they're talking about a 120/208, this relay will be rated for 120. But if you have other voltage, this relay would rate for other voltage. So if from your line A goes through this one, if you reach 120 volts, you will be energized. When this one energized, you will affect this part. This is probably a normal close. When this one opens, so your overcranking relay, the circuit goes through here. This one opens, you will de-energize your overcranking relay. Then the generator will have enough voltage. Then your transfer will come still to operate. But if this one time out first, then you will causing this overcranking timer, this normal close contact to become open. When this one open, you will stopping this starting relay. So this is in the circuit before. You can see this one is down here, overcranking timer. If this one opens, then your starting relay gonna be de-energized. You're not gonna be able to start in this one. So that's how it works. Then once the generator have enough voltage to build up, this generator voltage relay usually pick up, they said, at 90% of rated voltage. Then the normal open generator voltage contact close, and the warm up timer is energized. So this WOT is a warm up timer. When this one energized, we close this one. So when this one close, the warm up timer will become energized. The generator warm up, the normal open warm up contact close, and the transfer switch relay energized. So I think you'll have a warm up. This one, yeah. So when this one, the warm up timer times out, if we close this warm up timer contact, this is the contact. So then you will have the power go through this transfer relay. When this transfer relay energized, you will energize the somewhere here. Yeah, transfer switch. It will close. Yeah, close this one. This is a normal open, so close this one. When this one close, you will have the power go through this one, follow this line to energize this motor. This motor is to operating those transfer switch. When this motor start to move, it will move the one type of this transfer switch. They use robotic arms. The robotic arms is another picture going to show you. You have a motor inside can move that a lever inside to make a connection to one side and another side. So when this one moves, you will first open the normal breaker. You will causing those, because this is a breaker before make type of the switch. You will open this side first. Then once that side is open, then they will close the power on this side. Because your low is here, then your generator will supply the power to the low. This is the robotic arm. The motor will turn a wheel with a bar and arm attached to it. This is the bar and arm. This is two switches, two circuit breaker. So when this moves, it will causing one of the breaker to open first before it closes another breaker. I think that's it. So we go a little bit over here. There's a bunch of components in this drawing down there. You have to, let's say, know the names. What's the name of those? Like you guys ask me, what's WT or what's HOT, and or what's CDT, right? So you probably we get asked what's those components down there. That's why this one is the PowerPoint only talking about when the normal power fail, how they transfer to emergency power, and on the D2L there's another piece of document talking about when the normal power returns, how they're going to transfer the power back to the normal.
Hey, Jack.
Yes.
You're not sharing your screen right now, right?
Yeah, no.
Okay.
Yeah, so I like you guys to read both the document, and you need to know those components, at least the name inside, and the things I explained to you before. What's the purpose of those things? Or at least if I was you, I will print them out or have something handy when I do this exam, because like I said, you probably don't have enough time to go through lots of detail. Sequence of event, they're not gonna ask you go through all the steps, but they might ask you a question says when, let's say, when this relay coil energized, and or maybe just like a simple true and false question, right? They will say when this relay coil energized, then another one will be also energized or de-energized, or those type of question. It's possible. Or another way they can ask is which one energized will causing the generator to start, or which one the de-energized will causing this transfer switch to operate. So it's not gonna be very complicated, but it's still that will be, let me think, at least you will get about a few questions from there. So better say something down here. Okay. So I saw we have 47 people down here, and except me, we have 46 students down here, right? I'm not sure how much of you guys is actually here, but anyone here, like I think Hayden's here, and Travel probably here, Yifan's here.
Yep.
Right? So anyone here, yeah, lots of you guys are here. You're gonna be my witness down here, okay? You need to have this piece of drawing ready for the exam, because some of the questions they ask you, they might not give you this piece of drawing. Okay, so they might ask you this, UVS is under voltage sensor. Because I know when they build that exam, some simple question, they didn't attach this piece of drawing on there. And last term, a guy sent me, he got asked that question about the UVS. He said, yeah, the question I got asked, I don't have the drawing, so UVS can have a lot of different meanings in these electrical trades. I said, doing the exam, before doing the class, I told you, you're gonna test on this drawing. So you better have it ready. So anyone here, you're gonna be my witness. I told you, you need to have this piece of drawing handy when you're doing the exam. If any of the question, they ask you anything on here, you didn't say the drawing, you still need to be able to answer it. And don't complain to me. Otherwise, I will say, I got a lot of witness. I told you this piece of drawing is for your exam. No, on your exam on Friday, they're gonna ask you this for this piece of drawing. Yeah, for this topic, emergency power. On the IPs, they're not gonna do that to you. Now on IP, they're not gonna give you this so complicated piece of drawing to ask you to figure them out. Okay, you guys want to take a break? Yes. Okay. Back at 12:59. Okay. Did you guys see a question pop up on your screen?
Yep.
Could you guys answer it? That's it? No more people? Anyone did answer the question? So I only have a 31 people answer the question. I have a 44 student here. I guess the rest of 13 or 12, they just die in my Zoom meeting and disappeared, right? Because you guys gonna post anything in the Discord, and they will know what's important to know. Are you guys doing that? So half the guy taking the morning class, half the guy taking the afternoon class. Okay, 35, I guess that's it. The result is not making me happy. First, are you gonna buy a automatic transfer switch in your home? No, you're gonna use a three-phase system. That's why I said usually, right? So usually it's gonna be 3-pole. That's for sure. If you answer single pole or 2-pole, that's not usually. Second one is double throw or single throw. Are you just use it to disconnect something, or you're gonna switch in between both sides? Yeah, so it will be 3-pole double throw. Okay. Oh, come on, you guys. We call the 3-pole double throw. No, that's on-off auto. It's totally different than this one. This one is talking about, where they're talking about is so you will have let's say switch arms. How am I going to draw this in? Maybe draw like this. Then you will have here's your low, here's your normal power, normal utility power, here's your backup power. So if this thing only touch one side, that's called a single throw. If it touch both sides, then it becomes a double throw. Like a 3-way switch is considered double throw. A single on-off switch is considered a single throw. But you're gonna bring 3-phase power, so you need 3 poles. How should I say? Should I make you guys feel bad to crying, or should I just nicely pat on your back, said, "Oh, okay, don't worry about it. You did all good."
Make them cry.
Make them cry. Okay, so as an electrician or electrical apprentice, this should be your basic understanding of the circuit, the basic understanding of the how the switch works, right? Nowadays, the IP will be have more and more those questions. You probably have to based on your knowledge to conclude the answer, not like before when the time I did the IP. The question is pretty simple, straight, and now the IP question become a little bit. I think you actually need the knowledge to answer it. Can you grab one? I think another way the IP they try to make this is I don't know if you guys notice or you're ever working with someone. I'm not against those people from other country, right? But they came up here, they get a letter from their original where they came from. I'm from China. I know lots of people. They said that they've been working as an electrician back in China, and they just get a letter. They come here, they go to challenge the IP exam, and when they pass, they got a ticket. They said that they are electrician, but they never did any electrical work anywhere else. Okay, we're gonna move on to the last topic, the UPS system. Yeah, that's why you know why people call me the mean Asian. I make my student cry in my class and just show them a picture of the tissues. Okay, the last part is the UPS system. Okay, we still have to cover some of the code. So in here, the UPS is an uninterrupted power supply system. They have all different type. There's a larger one for industrial or commercial use. There's a smaller one for your personal use. You can buy those. Depends on if they give you pure sine wave or they just give you modified square wave. The price can range for the smaller one. I'm not talking about industrial one. The price can vary from $100 to maybe $1,000 or more than $1,000. Also depends on how long they can last when you put a low on there, because the battery bank inside will affect how long you can use that for out power situation. Okay, here's the test, the thing we just talking about before. The engine driver generator, when the power lost, how long takes them to go online? Oh, and then you better get a good mark on my exam this time. I'm gonna believe you for your excuse for last exam. Good job. Yeah, 8 to 15 seconds. If the line voltage of this alternator is 600 volts, what's the voltage across each coil? Across each coil, how many coil? How many coil? D will be the right answer because you have to divide by 2 coil in series. Okay. The short-term running of emergency generator for testing purpose is commonly referred to as exercising. How long and with how much loads?
$30.
Yeah, 30 minutes per week and full load. Huh? Milan and the Park didn't pay attention in my class. You guys got a 30 minute. The PowerPoint says at least 30, but we wanted the full loads. Preferred one would be full load. The device automatically maintains a constant engine speed during the load changes on a generator set is called okay, this time is right, governor. Okay, did you guys get all the questions right? Yeah, I think most of you guys did pretty good. UPS is an electrical device. They provide emergency power to a load when the normal power fails. The best thing between UPS and the backup generator is they don't have an interruption between the power failure. They can constantly provide the power. Most of them have a battery and an inverter and some control equipment. We provide near instantaneous protection from the input power interruption. They have offline type. Offline type is a little bit cheaper. Online type is more expensive, and the on-battery runtime of those UPS is relatively short. So if you have one just for home uses, before we don't have the laptop is not so common. We usually use those desktop computer. And if you do something, the power interrupt, all the document you get is gonna be lost. Oh, that's your game ring. Yeah, I think the instructor, he took this picture. That's probably a really old set at his home or he found somewhere. But now the laptop is okay because you have the battery power in there. But still, people were using them for the gamings, for the entertainment unit, or for a bunch of other uses. Most of them have a power condition unit inside. Most people will use the online one. The offline one usually is actually used in commercial and the industrial. Because the online one, for those smaller units, it's easy to build an online one, no problem. Most of them have a power conditioning unit inside. So if you have a power surge or power swelling or something, might be the frequency or the voltage or something happen on the power line, they can filter those things out and still provide you with surge protection and filter out all the noises. Converter and the inverter, UPS unit, because you use a battery, so you need to have a rectifier or certain thing inside. You need to convert that into a DC to charge the battery. And also depends on how this thing is connected. Then you have to have an inverter to changing those DC back into the AC to feed the load. So sometimes, depends on the configuration, they can let the normal power go through of them to the load, or if the normal power fail, or sorry, the AC we also charging the battery. When the normal power fail, the battery will supply the power to the load through the inverter. So first we're talking about offline type UPS. The UPS is in the standby mode, and the inverter is now in the primary power path. So you can see here, it provides you with surge suppressor with a filter to go there. And at the same time, they have a battery charger, battery, and the inverter connect into another path. So when you have two separate paths and they have a transfer switch inside, this is considered offline type. When there's a power failure, the transfer switch, we transfer the normal power to the backup power side. There's a time delay in switching in this type of operation. Usually it depends on what type of transfer switch you're using. Mostly they use a static transfer switch because a mechanical transfer switch is not going to be operated so quick. So the static transfer switch depends on also the condition, the build. They will transfer them between 2 to 12 milliseconds. Compared to other UPS system, this one is not so expensive because they don't have to continuously bring the power through here. In here, I think, yeah, we're going to talk about that one later. No problem. Online type. Online type, the battery is always connected to the inverter, and no power transfer switch are necessary. The battery charger or converter is larger, must be able to carry all the load. Usually, it's a very large, generate more heat, and because this portion is always online, so they will shorten the lifespan for the unit and the battery. If there's an internal problem, they will have some kind of protection or transfer switch. They can switch back to the AC with the transfer switch. So this is the normal power. The normal power will always go to the charge controller, converting into DC to charge the battery. Then the battery supply the power to the inverter back to AC to supply the load. When they said here is if this portion, they might encounter either your charge controller is bad or your battery is dead, or sometimes you have to replace the battery or your inverter have a problem, they can switch into the top portion. In the top portion, they don't providing the UPS function, but they will still have those surge protection and the filter function. That's why they call it always connect to the inverter or always connect into the line. Also, a pretty common one is online UPS. They don't have the one like before. They have a transfer switch. You can bypass those inverter and batteries. So you supply, charge the battery supply power to the inverter, and this one shouldn't be here. So it just directly go to the low. This static switch actually should be here. That's this transfer switch is not a static switch. Yes, the online one, they always using the power from the battery, and at the same time, your AC is charging the battery. Most your home type, yeah, because when you try to transfer down here, you don't need this static switch because your power is already come out from the inverter to the load. Most smaller one using for the home is this type. The offline type, so this one, it's also we use a static switch because when we talk about static switch is those electronic switching function. It's not like a mechanical switch because like we're talking about that ATS, we're talking those mechanical switches. It takes time to switch sides, right? But those that one cannot be changing so fast, take seconds to do it. But the UPS, we're using the static switch is try to minimize the transfer time because you want to keep continuous power. Yeah, they use both for offline type and use for online type. So they also give you the disadvantage because if any of the component fail here, there's no way you can use this one anymore. This is not a very common type, but it's also there, and we're gonna they want to test you on this one, so you better know this one. They call a ferroresonate type of UPS. They operate at the same way as an offline type, because you can see here the battery charger, and the inverter is not on the main source or on the main path. Your load mostly at the normal condition is controlled from this side, goes through this side. Only when you lost power or something happen on the top path, they will try to transfer to this one. So this is an offline type. But they use transformer down here for the purpose of, you guys know transformer use magnetic mutual induction, right? So when the current stop, the magnetic field built up by the transformer, they will try to keep the current going for a very short moment, because those energy built up in the magnetic field, they will convert back into as electrical energy. So for that very short moment, to converting that magnetic field stored energy back into the electrical energy, then your transfer switch can switching into the battery power. That's why they're gonna use a 3-winding transformer. So this is the main function or main feature of this ferroresonate UPS. They have a 3-winding transformer. So they can, the collapsing of magnetic field, we supply enough electrical energy, and that will cover the time where you need a switching from the normal power to battery power. Yeah, because you want to eliminating that short moment of transfer time to make your load loss power. There's some advantages, some disadvantages down here, but the important thing is they got a 3-winding transformer feature. That's most important. Another one called a line interruptive UPS. This is also you need to know this one. What it does is power normally direct taking from the utility with more active filtering for better waveform. The inverter is always connected to the load. So your power is come from here, then the inverter is always here. Just try to do some filtering on the signal condition. At the same time, they will also to rectify the AC to charging the battery. So there's a charging to the battery. Rectifier circuit in here. When the normal power fail, the inverter will take in the power from the battery. So if this part is a fail, then the battery gonna supply power to the inverter to continuously to supply the load. Because the inverter is always connected to the output, there is no break in output power doing the switching from the utility to the battery. It's better than the offline type. So because the offline type, you need to take time to switch them. And it's also have a little bit advantage for the online type is this battery, as long as you keep it charging, like it's now gonna be like the online type. You charge it and you drain power. You charge it and you drain power. So this one, only when the normal power fail, the battery need to supply power. So the battery can last longer in this type. You don't have this one on your PDF? No. This is a small one. So for this one, the important thing you need to know is your battery is got charged through a rectifier circuit inside the inverter to charge this one. And also when the normal power fail, the line missing. The line doesn't matter. You can draw the line. Update the PDF. Okay, I can do that. So this one, we have a better performance than the offline type because it take less time to get the power back on, and almost like instant. You don't have any disruption when the power failure. But you gotta understand here, we have a rectifier down here to charge the battery. Some other type, they give you a drawing here. They said similar to the offline, but additional multi-type tab variable voltage auto transformer. This is special type of transformer, can add a subtract power coil for wire, increasing, decreasing the magnetic field and output voltage. Tolerant continuous under voltage brownout and overall voltage surge without consuming the limited battery power. Instead of compensate by automatic selection different power type on the auto transformer. So this is using the auto transformer. The load here, we're gonna say, okay, the load requires 120 volts. So if your supply power is normal, the supply power will charge the battery. And if the input power is 120 volts, they will connect onto the 120 volt input. But if your input power increase, they will change the tab to, maybe you increase to 130. They will change the tab to 130. If your voltage drop lower to 100, they will change to the 100. So it kind of providing you always with a constant stable voltage for your 120 volt equipment requires. Then if you actually lost in power, then the battery gonna supply the power through the inverter. So this is one type of the interactive UPS. They give you some good benefit down here. Another type they call the rotary UPS is actually using a mechanical means and with a backup generator. So this is a slightly old type because you constantly have to run some motor to keep those flying wheel moving. So you are kind of like wasting the power on there. The system have seen so far consider static, use battery. The rotatory use a high initial of a high mass spinning flying wheel to provide short-term ride through power in the event of power loss. Because your generator gonna take about 8 to 15 seconds, or this diesel, they give you another time. So if this one taking that time longer to come online, and if your normal power fail, this load have to wait for this one to come online. So what they did is when they have the normal power, they're gonna driving this motor generator kind of a motor. If you're giving the power to the stator, it will be keep running as a motor. So the motor is driving this heavy flying wheel. The heavy flying wheel gonna start rotating. And once this one rotates, your motor is keep driving it. But if you lost the normal power, so your stator is not going to get any AC power to keep the rotating magnetic field. But then the inertia of this heavy flying wheel is still keep moving. So now this moving flying wheel will induce a voltage in the stator, and the induced voltage, because once you lost there, this supply probably got a disconnect or whatever. The induced voltage will keep go to supply the load down here. That's how they works. Here's some picture of probably in Cisco data center in Texas. They have a full 2,200 kVA. This rotatory UPS. They constantly being spent by electricity from utility. Once the power loss, they can provide power to the entire data center for 30 seconds. And the generator will become online in 15 seconds. I think one way is before the storage battery capacity is not so big, and also the situation down there. So now you probably can get a large UPS battery bank to supply for a short moment for those loads without any problem. Because this one, you have to keep the motor moving, and but probably they got a lot of money, and also it's not so green. You keep running that heavy flying wheel. The advantage is they have a high current output, and usually used in more than 10,000 watt application, and they will last very long. Can provide power factor correction, as most motor used synchronized motor. They use synchronized motor to do those things. But they are expensive and more maintenance. And they require downtime for maintenance, those type of things. UPS protective feature. They all offer the protection for surgery, sparking, or electrical noise. The basic type of surge protection is, we talked about this one, right? Metal oxide baryster for surge protection. Connect across the income line. So if you have a too high a voltage, this one gonna be conducting to limiting the high voltage. They also use some type of line filter. The line filter could be sometimes is a capacitor, sometimes is a capacitor and inductor combination. They can filter out the noise, and they also can filter out different frequency signal. Now we're talking about the static bypass switch. Static bypass switch is almost all online type or even offline type. In here, the bypass switch is talking about this one. Should the inverter fail, the static bypass transfer switch ensure the load drop automatically onto the main input feeder with only a fraction of disturbance to the low, allow a way to maintain the UPS without disconnect the load. So here's the UPS. They will supply the power, here the battery and to the load. But if you want to do maintenance or you want to do something on here, and you try to get the power still going, this static bypass switch will function. The top is a manual maintenance switch. This is the static bypass switch. So they can switch the power from this part to go through this bypass switch to the low. The operating speed, this is red, so you need to know this number. Yeah, this is the online type. So this number, you have to know. For a static switch is they consider electronic solid state switch. They can do a transfer pretty quick. They said some of them can transfer the power in less than 200 microseconds. But plus other things you're gonna do. That's why we usually said it's transferred within 3 to 5 milliseconds. And in here, it's still okay because we're using 60 Hertz. So a full cycle is 16.67 milliseconds. You can transfer the power within 3 to 5 milliseconds. You are only about less or close to a quarter of the cycle. No. This is you're doing the maintenance. This part is inside the UPS. But if you want to do something on your rectifier or on your inverter or on your battery, you still want to keep the power goes. So that's where they use this. It's a still. This is you can consider this is a utility power. Just like if you have this one, yeah. No, the power is now go to the inverter. Normally, this is if we're talking about online one, so normally power goes through here, go to your battery, come from the battery, go to your inverter, go here to through this bypass switch, go there. But if you somehow you maybe disconnect the battery or this thing is broken or this thing broken, this one will automatically take in the power from the top part. So this is doesn't matter who supply it. You could have a utility power or you could have a backup power. So this is talking about how they can make the transfer between different type of the switch. This is not what what should I say? This is not a static switch. This is basically a kind of mechanical switch inside. So those types, they usually have a normal task and the bypass function. It's for they will disconnect from one. They will contact another side before they disconnect from the original side. So this type of switch is considered make before break. And also you can thinking about all those bypass switch is considered mostly the bypass switch is make before break type of switch. So they tell you the step goes through here and power flows through UPS in normal state, and the power flow through the bypass switch. So normally you will have a power come here, go through here, go through here, go out to your low. Then in the second stage, the power goes through the bypass switch also. Power will go through here and also at the same time go through here. Then the third stage, the power only goes through here only. So they don't go through the UPS anymore. When you have a power outage situation, the UPS can only providing limiting the power for limited time. Otherwise, your battery gonna run down. So normally they will have a generator UPS combination. Your critical load will always be supplied by the UPS. Then when the generator take 8 to 15 seconds to come on, then your essential load will also be supplied by the generator. At the same time, the generator gonna charging the UPS battery and supply the power to the critical load. So your critical load will never lose power, but your essential load will lose power for a short moment before the generator come on. Your normal load will lose power during the normal power outage. So for this drawing, you need to know what's going on down here and which load is supplied by what. So that's important to know. Maintenance. Here's a battery cabinet, and here's your UPS. Here's your distribution panel. You got to do visual inspection, verify cooling, operating on both the UPS and the battery room, check for alarm warning on the unit. So usually they will monitor the operation. Something goes wrong, they will show you. When auto transfer occurs, UPS start protect critical load, and then generator come out, charge the UPS. No, the UPS depends on. So this UPS is always connected here. So either you have an online one or you have an offline one. Online one will be better, right? Because you never need to transfer them. So the power from here, we charge the battery and also go through the inverter to go to your critical load. But if you lost power here, the critical load is going to take in the power from the battery, goes through the inverter. Then when you lost power here, the transfer switch will start a generator, and then after that stabilize, you will switch to that side. So then the generator will also charge the battery. The battery will have the power to go to your critical load. But because if you continuously charging the battery, it's no problem. Only when you lost power, then the load gonna draw the power from the battery. Yes. There's a quarterly maintenance, and there's annually maintenance, and that usually the UPS manufacturer will supply those requirement, or your company, if you're using them, they will have a certain procedure. As long as you follow, that should be fine. And I can't think I know this guy. I don't know. Yeah, the battery in the UPS, when you have the AC input, they are now using. But if your AC input is don't have the AC input, then they need to take the power from the battery. Okay. So you have a 100 amp hour battery down here. If this AC power is here, and it will charge the battery, at the same time, you can draw the power from the battery, but the battery is always holding at 100 amp hours. You're not going to use any capacity down here. If your AC power is failed, you're not going to charge it. So when your inverter still supply the load, this capacity will start dropping. So this AC power doesn't matter come from the normal power, utility power, or generator power. As long as you have the AC power in, your battery will holding its capacity, no problem. I think that's all you have to know for the UPS. So you will have about 4 questions from the UPS. And those are the one I told you it's important. And I believe only except the normal load will lost completely because nothing gonna supply them. The generator only gonna supply the essential load and the critical load. They're not gonna supply the normal load. Yes, no? Okay. I guess it's 1:55. Maybe tomorrow morning we take a little bit of time to cover the code code section. The same thing we do is I'm gonna go through some code rule with you. Then the rest of the morning, if you have any question, just bring them. We can discussing or solving them. Think I don't have anything more to say today. So if you don't have a question, you can go study yourself and you can try those online quizzes because sorry I didn't open them yesterday, but I opened them today. Also, I will try to converting. You guys said this UPS one wasn't in something's missing in your okay, I will try to save a PDF. Then I will upload them up there. Yeah, that's why I like to give you those additional notes. Okay, I think I have them. Just let me upload them. PS, UPS. So it should be there, emergency power system, UPS. Yeah, you're welcome. The generator one also missing fuse line? Sure. Yeah, you're welcome. Anyone check the generator one? Do I missing slides on there? Yeah, if you don't come to my class, missing that fuse line, you deserve it. I heard you guys try to post everything I said onto the Discord. Maybe next time I should find some way to preventing that. Or I totally don't tell you anything is important. You gotta study hard to get everything in your head. I think I saw someone have a question. The battery charge one to prevent the overcharge. You don't need to know that. All you need to know is what each component does. You're not gonna design in that circuit. Oh, for your knowledge. Okay, now you're gonna pay extra money for me to show you that. Okay, I will do one more time. I have a picture here, right? I just do from here. My terrible drawing, my terrible drawing. So, if for this one, I want to charge this battery, required battery voltage, I want the battery to reach 13.2 volts. I will put a bunch of resistors down here, and I just gave an example because each one have a different values. So I will have a Zener dial here, 5.8 volts. And then the potentiometer sets here, when this one reaches 13.2, I can have 6 volts down here. So when you start charging, your battery probably, let's say 11. Yeah, this one doesn't right. Say your battery is starting at 10 volts. Because when the battery is 10 volts, and the voltage down here will be also lower. If we consider that's a proportional, 10 times 6 divided by 13.2. So you will only have a 4.55 volts down here. When you have that, direction is the current is always go this way. The current always go from negative to positive. Don't need me to give you the direction. So because this voltage is too low, it's lower than 5.8, so this Zener dial is not gonna conducting. The Zener dial not gonna conducting. You don't have the gate signal here, so this SAR is blocking. When this one is blocking, and there is no current pass through here, so you will have a current go through this battery, and because the positive side on here is go across here, and this terminal will have a higher voltage than this one, so you will causing this this dial forward biased. This dial forward bias, you can have a current go through here, and this current will triggering SAR. So this one is conducting. When this one conduct, the current will go through from the cathode to anode, So you will have a current go this way at the normal situation, but no current here. So this one conducting, you will charge the battery. I don't have any other color. So this battery get charged, the voltage will start rising, right? When the voltage rise to 13.2 volts, now this one reach 6 volts. When this one reach 6 volts, it's higher than the Zener diode's rating here. So there will be another current. It will go through here. It also goes through here. It will go through here. When a current goes through here, it will causing this SCR to conduct. So now this SCR become conduct. When this SCR conduct, you will have a current go through here, go through here, go through there. But this SCR conduct, we causing the voltage down here to drop to only maybe 1.5 or 2 volts. And here, you only have 2 volts, but this side, you have 13.2 volts. So this dial gonna block. When this dial block, and the gate, you don't have the gate signal down here, so this SCR gonna block. When that block, you don't have a current go through here anymore. So all your current is, you will have a current go through this side, but you're not gonna have a current go through there. You think this is smart? This is maybe this type of circuit is older than me. Nobody using them anymore. Any new type of a charge controller, they don't use this anymore. Now it's all those microprocess controlled. You're welcome. Okay, I'm gonna give you a hard time. You better get a high mark on this topic. Otherwise, because this morning you're late to my class, you see, even asked me to punish myself, even I'm late for 1 minute. Okay, I'm gonna send a letter to your parents. For Asian, you only pass at 100%. Otherwise, you fail. No, your mark's good enough. And I know you're working hard enough also. I heard other people told me you spend lots of time study, so. But I can give you guys some idea. That's just from what I heard. Because they changed the IP exam. Now the IP exam looks pretty hard. The passing rate also dropping across the whole province, also at the BCIT, the passing rate is dropping. So far, I found if your average for year 4 is above 80, you will have a very good chance to passing the IP. Before is like when I go to BCIT that time, the IP passing rate was at 90 to 95 in that range. yeah, if you don't pass, depends. I'm talking about that slightly later. But now, the BCIT for the last 3, at least I know, for the last 3 IP, the passing rate is between 50 and 60%. So my time is you passing year 4 in BCIT, you almost like a guaranteed you pass IP. But now, if you don't get your mark above 80s, there's a very good chance you're not going to pass in IP. Okay, so if you're passing year 4, you could be a journey person in BC, but depends on your company. If you're working for the, let's say, the union, IBEW, you don't pass IP, they never sign your ticket. So if you are in the union, you don't pass IP, you'll never be a journeyman. But if you're working for a company, they don't really care, like those lots of residential company, then they will say, yeah, okay, you are a journeyman in BC, good enough, because then they know you can't go anywhere. They just said, I can pay you less. Yeah, you can take your IP in other province, but why don't you just, because the IP exam is across Canada, there's nothing like the IP exam in BC gonna harder than in Ontario. As long as you can, you live in Quebec, yeah, that's fine. I think the IP interprovincial exam is the same everywhere. They just have a big question bank. They're gonna pull at a different time, put different questions, but those ones are pretty organized. They will say almost like a different type of question, different level of difficulties. It's not gonna say, I go to Quebec or Ontario, I'm gonna write an easy IP. No. Yeah, I don't have too much idea. All I know is if you have a red sale on your ticket and you go to another province, you want to starting as an electrician, I don't think there's too much problem. But if you want to become like in BC, we call the FSRs. That's in Alberta, they usually call master electrician. Then you have to take another exam. But if you only pass year 4 down here, then you only be qualified as a journey person in BC. You go to other province, you cannot be journey person. Okay. The electrical code, the code book we got is published by CSA, and but that's not the BC code. The BC government have to adopt that code. They said, okay, 2018 CEC code, they adopt it, or the safety authority, or now I think they have a different fancy name. They call some technical safe BC. They either make some adjustment for certain code rule, or they have some bulletin or something. Then, because the CEC code got adopted, then that will become the BC electrical code. Then when each province, like I believe in 1 year, one version of the electrical code, because they have something mixed up in there. So each province, they have the right to say, I'm not going to adopt this version of the electrical code. For 2015, BC take more than a year to adopt them. For 2018, also BC take a pretty long time to adopt them. That's why the provincial, that time, I believe Quebec didn't adopt one version, maybe Ontario didn't adopt another version or something. That's how the different provincial might have a different code. But in the school, or on your IP exam, we don't care. Only when you do FSR in BC or mass electrician in Alberta, those exams will more relate to the provincial code, because you also have the safety regulation, safety act with your FSR exam. But for the IP or anything, normally you just use the general code book. No troubleshooting on my exam. It's not going to ask you which part of system is not working or something. They will just say something like, okay, is this coil is normally energized, or this coil is normally not energized, or maybe this contact. They will say this when the normal power is there. Maybe which coil is energized, which coil is not energized, or when the emergency power come on, or when the transfers happens, and which coil energized, which contact is closed or open, right? They're not going to ask you to explain the whole thing. For Hades' question, the IP is called the interprovincial exam. If you fail the IP, you just cannot be called a red sail journey person. So you cannot go to other province to work. But in BC, as long as you finish all your 4 years in-school training, and you pass that, and you have enough working hour, you still can become a journey person.
Hey, Jack.
Yeah.
Sorry to interrupt you, but I was just dealing with my my EI stuff. Do you remember our start date of school?
You don't remember which day we start school?
Everybody said the 25th. Okay, perfect. Thank you. No, I didn't remember.
Oh, you can call 24th, because that's a holiday, right? But if you want to start your IP, you want to get paid the whole week. Yeah. Did you hear me? Put the 24th. You put on January 1st, you're going to get in big trouble. Okay. So we all good? I think for the EIs, as long as your company send in a form to the Service Canada or something. I remember when I come to school, the first time, because I take the foundation, so I didn't take year one. The second year, I have to wait 2 weeks to get paid. And third year, fourth year, I think I received my EI right away. Sometimes they screw up, so especially during the pandemic, and I guess that's probably make the things more problem. But usually, as apprentice training, right, they will not do anything. You can get pretty quick. Reference number from Working BC. I didn't know. Maybe they changed something.
Yeah, they make you apply for, that's the problem that most people have. They make you apply for Work BC first to get that reference code, and then you have to give that to EI. So a lot of people apply for EI and then they don't realize they have to get that reference code, so it never goes through.
I guess through those just I heard something is they said a high school kids maybe in 2019 he working the more than how many hours, 500 hours or something, right, for part-time job. Then because 2020 come the pandemic, even the guy still in the high school, he's still qualified to get those $2,000 a month EI payment for the pandemic. But then make you guys actually working and go to school to get EI so hard.
A couple of my cousin's friends did that. They got out of high school and they were like, they had part-time jobs and were collecting $2,000 a month from the government. It's crazy, like, because they just wanted to give it to everyone so that no one got left behind. But they'll come back and get their money. I guarantee it. They won't let that go unchecked.
Yeah, but for you guys, you work, you come to school, you're supposed to get EI pretty easy. Now they make the process so complicated.
Yeah, it's frustrating for sure.
Especially you think now, right? And the pandemic, and I understand, like especially Caucasian kids, you guys now living with your parents or living at home, most of you, some of you might. Now like Asian kids, right? When they go to school, or most of the time they're living at home, they don't pay for rent, they don't pay for the food. The parents will, okay, here's the room for you, here's the food on the table. Then if you don't get your EI payment, you're gonna be really struggle lots of things. Shane, do you pay rent to your parents, and you have to pay for the food? Really? Yeah. That's weird. You should go back talk to your parents. Say, are you Asian?
When I was 18, my dad said, "Good luck," and I've never seen him again.
Oh, that's bad. They want the Asian respect and then go with the Canadian standard. Whoa, that's worse. Sorry for you. Yeah, that's a few years ago I heard a story. There's an Asian kid and he graduated from high school. He didn't find any job or anything, so his parents forced him to take the foundation at the BCIT. And then the foundation is pretty expensive, right? I think it's almost like $6,000 or $8,000. No, I don't. Oh, $4,000 maybe that time. So he failed. Yeah, I don't remember exactly how much it is. He failed the first time because he don't have money. His parents pay for it. He failed 3 times or 2 times because the instructor teaching that it's a 6-month program. He failed the first time, come back to take the second time. He failed the second time, come back to take the third time. I always almost think to myself, because Sparshall or those company, those private institution, they charge almost like 3 times more than BCIT, right? So I said, why don't you just go to Sparshall because they guarantee you a pass? Oh, you go to Sparshall. I know they don't give you good training, but they guarantee you a pass, right? Yeah, I think somewhere I heard it's 12,000. Yeah, you can get a free do around. Really? Okay. It's just a pandemic. So unless Yifan, you want to fail this term, come back in September, in October. Okay, nice to chat with you guys. And any questions? Nope. So I will see you guys tomorrow morning.
See you tomorrow morning, Jack.
Yeah, just study this important thing and do those online quiz. You should be fine with this topic. And you've been doing 2 exams of my one already, so you know my style. Okay, see you guys. I'm gonna end the meeting now.